All right, so welcome everyone again. We are going to have a small presentation and demo, which is called Written Sensors Integration and Use Cases. My name is Barbara, and I'm taking care about written project in Bratislava, and I'm responsible for processes and Scrum. Scrum processes of our team, and this is Zuzka, my colleague.
Yeah, hi everyone. I'm Zuzana Hatcharikova and I work as a software engineer here at Accenture for about 7 years already. And yeah, that's it.
Thank you. All right. So, what actually Rhythm is? So, maybe let me tell you what Rhythm is about and what is the main goal for us. Rhythm combines observations and context, identify behavior, and orchestrate the natural flow of interactions between human and machines. So basically, you can imagine Rhythm as combination of device, data analytics, and software implementations which helps people to do their job or make their life easier. Our goal is not to replace humans, but help them to do their job more effectively or easier, or possibly eliminate any mistakes. So simple. Rhythm means symphony and sync between devices, software, and people. Next slide, please. Thank you. So what we are working with on the Rhythm. Rhythm can cover various use cases in very different industries. In our team, we are working with AI, hardware, and sensors, and of course with the architectures and develop software itself. Now I will give my word to colleague Zuzana. We are going to show you one interesting demo itself, how sensors, humans, and software can work together.
All right. Thank you, Barbara. Where should I start? From this whole rhythm definition, I like to be focused on the word observations. Because what we are going to see is some sensor processing, because yeah, we are living in a world where there are millions of types of sensors, which some of them we can perceive, like, I don't know, some visuals and audio and these kind of things. Some of them, unfortunately, not, like, for example, radar, or I cannot say what my exact GPS location is at the moment, just by some nature of me, and these kind of things. And what we have prepared for you is a demo that is appropriate for these times that we are living in. COVID times, we need to make sure that we adhere to the rules. We need to make sure that our rooms are not overcrowded and these kind of things. And this is this case for that. We are going to be using our device. It's called our device, which is actually this one here, even though it's not actually running. There are people different things, but this is the device that provides us with the information about the position, movement, and speed of detected objects. I don't know, it can be people, it can be animals, whatever we decide to track. In our use case right now, it will be people. We will be also, when we are talking about signals and sensors, we will be also using camera, but in this case, we are not going to process it. I don't know, we are not going to use any object detection or people detection via video. We are just going to use it as a help for us to make what we are seeing more understandable, because people see that the radar is pretty obvious, but it is still in some situations better to see what is actually happening in the scene. And even though in some parts of our project or our team, we are also looking into or tapping into the AI and machine learning, in this particular case, nothing will be involved in that. We will be relying purely on math and some calculations, algebra happening on the device. All right, so this is the demo setting that we had today. You can see, if you are watching the video, that we were right here in the Liquid Studio. You can see Barbara, my colleague here, my other colleague there. I was just overseeing the situation. And it is a recording. I'll move this Zoom step here. And right on the left, or on the right is my right hand, you can see statistics. Like, you will be seeing the live count of the people that the radar can detect. On the bottom, you will be seeing what is actually happening via the camera. And on the top, you will be seeing actual radar. So let's start to play it and have a look at that. So you see my two colleagues are just moving around the room, and then you see two representations of people being there. You could see some little ghosts there, but let's see. There is a field of view. This is the area that radar is actually able to cover. And since I have it really, really zoomed in because we are in a really small room, you cannot see, but if I was, this is just a map, and this is actually our office here at Plianska. Okay, so maybe run it again. I don't know if you were able to pay attention or not when I was explaining it. So yeah, you see Barbara, you see other colleague. And here on the right side, you could see the live count of the people detected and what is the actual average minimum maximum for the last minute, last hour of today. Okay, we will maybe come back to this as well, or once again, when we move. This, no. Okay, so let me tell you a little bit about the sensors that are available or that we are using. It is a radar sensor. It's a millimeter wave radar. It is or we are using short wavelength electromagnetic waves. And it is easier to display how it works with this simple image. There is a kind of signal which is created by the radar, and then it's transmitted by the antenna. The objects in the area then reflected back. This signal is received, and then here it's further processed. There is some further transformations happening and other transformations, which in the end help us to get detections, help us to know what is their velocity they're moving to us or from us, what is their distance, and also what is their angle. Here, once again, you can see that field of view, which is, in our case, 120 degrees, but depending on the parameters of the radar, it could be less or it could be more. And also the range, for example, there are short range, long range, 12 meters, 78 meters, depends. All right, one could ask, okay, well, I have camera, why would I need radar? Yes, but there are some situations where radar can be a little bit better or more accurate for your situation. Well, what are its advantages are these three. The accurate tracking, you can get up to 4 centimeter accuracy, which is quite impressive in my opinion. Then it is very useful especially outside. For example, it can work good in the nighttime. It can work good when there is fog, smoke, or whatever else, rain. And also it allows us enables us to track up to 250 independent objects. And what I mean by tracking, it's not about only recognizing that there is something, but also being able to follow it around. Like, okay, this is an object, I don't know, it's a car, is a person, and I'm following it around. And then when we are coming back to that original rhythm definition, we can use this and detect some patterns and then use some decisions based on that. All right? Oh, all right. Okay, I'm speaking slowly. What else? Okay, this is the simple architecture diagram. You can have a look at it from two perspectives. From the vertical point of view, you have devices, you have camera, you have Aurora device. Then you have service layer, where we have, on one hand, we have video streaming server. We are just using it in this use case. We are just using it for streaming video directly to the client. However, you could imagine you could have there some recording. For example, if there was event of multiple people or going above the threshold of capacity of the room and these kind of things, we could be recording like 30 seconds of, okay, why was that happening? Why there were suddenly too many people? Then episodic memory. This is another component that we are using. It is mostly based on time series databases. And what it actually does for us is ingests all the signals, not only from radar that we are focusing right now, but also from various other sensors that we could be using or integrating. It also orders these events, and maybe if you have just one device, it's not that powerful because you know always what the timestamp there was, but as you have multiple devices, the ordering of them and knowing which event came first, which second, is really important. And also serializes these events or this data for use by other services or in our use case by AI. not AI, but UI. Sorry. And of course, storage, in case you would like to store some data for later, for training or whatever else. When it comes to video, I mean, we were starting from the clean sheet of paper, so we could choose whatever we wanted, and we chose WebRTC because of the real-time communication, and that's why. Of course, if we were doing it on somewhere where there was already some camera system in place, we would be just joining and reusing that or building on top of that. But here, that's how it works. WebRTC, it's communication of video, data, and audio between two peers. And of course, if that's not possible, then there is still a possibility to go to another server. Okay, well, that's when it comes to radar, I know that I was saying that, okay, it provides us these angles and detection, these kind of things, but those data come with three types of information: detected points, clusters, and tracking. And most probably, let me show you what I mean by that. Okay, here is a video that my colleague was kind enough to do. Here you can see my colleague once again in the same space that we are right now, moving around. But you can see not only the pins, but you can see all the different points that are artificially a little bit bigger so that they are easier to check. But here, what I would like to say is that, let's go where. Okay, here you can detect singular points, but okay, we know that they are just points. We don't do anything about them. Another type of the information that we get from radar is the clusters. Those are merged points that have the same velocity, they are close enough, and they're moving in the same direction. And in this particular cluster, the radar also gives us information that this is the object worth tracking, worth looking into how it goes further. So that's why there is also this pin or this example of a person. Before the demo or before in the video that I was showing earlier, you couldn't see those points, and normally you wouldn't, but just wanted to make sure. All right, and let's go back. Some challenges that there could be, but those can be overridden or worked out when you have enough time to calibrate your device into a particular environment in production, either to the particular room or particular area outside or whatever. Are maybe sometimes not enough detection that you have to check your radar parameters, too many detection, or resolving multiple objects close together. As I said, once you have enough time to do calibrations and parameters, you should be okay, and those things should not be happening. All right, now I'm moving to the last part of the demo, and that is what I'm using for actual front end, because for the UI, it's very important not only to be able to understand and process the signals, but also actually showcase what they look like, so that people who are using these applications, monitoring them, looking into like, okay, they have a better idea and can immediately understand what is going on. So for example, here we are using, or you could be using also Matbox.js that and Matbox.js that allows you to showcase maps. We are using also some open source protocols for serializing data and these kind of things. I think last thing before I give my word back to Barbara, we will talk about other sensors that we could be possibly using for other use cases. Let me show you one last thing. Okay, this is another type of demo that it's a bit older one, but you can see from the visual perspective or from that nice UI perspective what could be done. Or this is what the actual UI could be looking. All right, I think that if I go back to presentation, I would like to maybe talk about, or I would like Barbara to talk about a little bit about other sensors or other use cases that could be done. Because I was just presenting this one particular, but that's not what Rhythm is all about. It's all about all of these things, I would say. So, Barbara, go on.
Yeah, thank you, Luca. Yes, we can definitely work with various sensors and or data coming from different services, instances, or devices. And currently, we have several use cases where we can use different devices. As Zuzka mentioned, HD camera, so just normal camera, then the radar itself, which we are using millimeter wave sensors, which are within 60 to 90 gigahertz usually. Then we are often using clear camera or cameras, and we are using the radiometric one. So it's radiometric, sorry, thermal camera that allows us to get the temperature information.
So that means not only pictures but actual numbers.
Yes, actually, that one. Which actually non-radiometric cameras gives us only those pictures and not those numbers, which is useless for us. All right, then we are using GPS module, which is just usual GPS, including an antenna that gives us latitude and longitude, then magnetometer and accelerometer. I mentioned just a few sensors we are working with, but we are not limited to work with only these sensors, and we can actually use whatever we want or it's needed. Slide please, thank you. As I mentioned, we are currently working on several use cases and in various or different fields. But let me mention a few of them. Suska mentioned in detail one, which was the space usability, and I will tell you a little bit more about the monitoring center. So, oh, sorry. Okay, if you imagine that, for example, in Bratislava, there is like 300 cameras which are monitoring the entire city. And someone actually have to look at all those cameras and see if maybe, I don't know, in Petržalka is something going on or not, or in any other, in another part of the Bratislava. But still, it's 300 cameras and maybe one or two persons. And it's not really realistic to actually watch all of those and be focused all the time. Let's maybe say you are working 8 or 12 hours and you have to work 8 or 12 hours just looking into all of those cameras and notice every crime or whatever else is going on. And if any crime is going on or is happening, you have to very quickly alert police, ambulance, or anyone else who can actually help to solve this situation. But you can do it. You can do it, or you can't do it, obviously. And we can actually help you with this with our Aurora device, for example, too, and also our UI. Those operators in monitoring centers can be alerted if some crime is actually happening, and they can directly and quickly take an action, call the police, call the ambulance, and actually go to that situation and solve it pretty quickly. And maybe save some lives, save some lives. You know, depends on the different.
Okay, maybe some example of what kind of sensor we would use, maybe some video, blur. So basically all of this, because it's security, so we would like to see and hear and what is happening in the event. So that would be much more, say that,
Usable.
well, not usable, but it would involve much more sensors than just one or two.
Yes, that's definitely true. And of course, it depends on the situation we are we want to use it in space we are going to use it. All right, another interesting case is train car coupling. Well, almost everyone knows someone who is working on rails, right? And when train cars are coupling together, it definitely requires intervention of the operator, which is there, like pushing those rail car parts together because it did not fit correctly or something like that. And not only in this kind of situations, injury happens. With again, vision software and sensors working together, we can actually guide train cars coupling together and avoid this kind of injuries and mistakes. At the end, again, less injuries, less money spent, less people who lost their jobs. And actually, we are at the end. There is lots of other use cases, and if you are interested in other use cases or want to know something more information about those we just talked about or have any questions, just do not hesitate to reach out.
Yeah, I might have gone over some details too quickly, or you might have some questions. Let us know. We should be available for a couple of minutes after that.
Yeah,
in some way.
thank you very much.